Hello everyone, welcome to this video. In this video, we'll be solving this question which states that for any positive integer n and any angle theta is given to us, we first of all have to show that in the group SL2, R, what is this? We have this expression. So let's first proceed with this expression. Here, we shall be using the principle of mathematical induction to prove it. So obviously the result is true for n is equal to 1 because when you take it this to be the power 1, so this is the same thing, and when you put 1 in place of n, you again get the same thing. Hence both the left hand side and right hand side match, hence the result is true for n is equal to 1. Next, we assume that the result is true for n, so that means this result is true. We assume this thing. Next, we wanted to prove that the result is true for n plus 1, so that means we wanted to prove that n plus 1 of this thing is equal to n plus 1 of theta, n plus 1 of theta, n plus 1 of theta, and n plus 1 of theta. This is what we wanted to prove, correct? So here, for proving this thing, we consider the left hand side, which is the power n plus 1, correct? So you can write it like this. This matrix raised to power n multiplied with the same matrix. Now we can use step 2. Step 2 says that the result is true for n, so that means the value of this whole complete matrix is equal to this matrix. So we can substitute it here in place of this matrix, so that we have this. Now what we can do, we can multiply these two matrices by simple matrix multiplication. So you can multiply this row with this column to get this entry. Similarly, you can multiply this row with this column to get this entry. Similarly, you can multiply this row with this column to get this entry, and you can multiply this row with this column to get this particular entry. So now using the formulas for trigonometry, you can write the first term as cos of n plus 1 theta, the second term as minus sine of n plus 1 theta, the third term as sine of n plus 1 theta, and the fourth one as cos of n plus 1 theta, correct? So this is what? This is actually your right hand side which you wanted to prove. So you see, we have proved that our left hand side is equal to right hand side whenever the value of n is n plus 1. Hence the result is true for n is equal to 1. Therefore, by the principle of mathematical induction, we have this result true in general for any positive integer n, correct? Now then in the next part of the question, they are saying that using this formula, you have to find the order of these two matrices, correct? And moreover, this kind of matrix is actually a rotation of the plane by a theta degrees, correct? So when if you wanted to represent the rotation of any plane by some angle theta, you can use this notation. This is used in many scientific equations, right? So this is the notation where you can use this matrix to represent the rotation of the plane. Now we have to calculate the order of these two matrices. So let's first of all name these two matrices. The first one as A, the second one as B. Right now, in order to find the order of these two, what we have to do, we have to find the positive integers such that a raised to power n is the identity matrix, and b raised to power m is also the identity matrix. Now we are taking m and n to be different. Why? Because n represents now the order of a and m represents the order of b. So we wanted to calculate exactly both of them. So let's start with a raised to power n is equal to I first. What is a raised to power n? It is this matrix raised to power n. Now you, according to the above result, whatever is in the power, that comes in the angle, right? So this is what we are doing. In this case also, the power is n, so it comes in the angle, so it becomes n 60 degree, n 60 degree, n 60 degree, and n 60 degree, like this. Now this is equal to the identity matrix, correct? So this is equal to 1 0 0 and 1, because this is the identity matrix which is present in SL2, R, correct? So from here, what you can do, you can equate the entries of the matrix. You can equate the corresponding entry. So you have cos n 60 degree equal to 1 and sine n 60 degree equal to 0, correct? So from here you have this thing. Now using the trigonometric relations, you can, whenever your cos is 1 and whenever your sine is 0. So this is obtained we have to solve both of them simultaneously. So that means we have to find that value of n which satisfy these two equations simultaneously, both at a time, correct? So you see your cos is 1 whenever you have it as multiple of 2 pi. Similarly, your sine is 0 whenever you have it as multiple of 2 pi, where p is, it could be any integer, correct? It could be positive, it could be negative. Why I am taking it to be positive? Because you'll see in a moment, because your order is always what? It is always the smallest positive integer. So therefore from here you can write 60 degree as pi by 3, because we are taking this to be in pi by 3, correct? So you have n is equal to 2p pi divided by pi by 3, which comes out to be 6p. But however, n, because it is the order, it should be smallest positive integer of such kind. So the smallest positive integer of such kind is obtained when you put p is equal to 1. So that means the order of a comes out to be equal to 6, correct? This is as simple as that. Similarly, for the case B, when you wanted to calculate its power, its order, you have to calculate what is the value of m. So substituting the value of b, which is the matrix raised to power m, and using the above relation, we have this matrix, this is equal to the identity matrix. Now equating the corresponding elements, you get cos m square root 2 degree equal to 1 and sine m square root 2 degree is equal to 0. Now you have to calculate the value of m such that both the equations are satisfied simultaneously. This happens whenever this is equal to cos 2 pi multiple of 2 pi, and we have an angle equal to multiple of 2 pi, right? So let's take p as some positive integer. Now solving this, we also have to convert this into radian. We have square root 2 degree. When you wanted to convert it into radian, you have to multiply it with pi upon 180, correct? So now it is in radian. Why I am converting it? Because I am taking the right hand side to be in the radian. So you see this pi and pi gets cancelled, so your value comes out to be this. So what is m? M is not exactly this. M is the smallest positive integer such that you have, when you raise it to this power b, you get the identity matrix. So you have to find that value of p which give you the identity matrix, and it should be the smallest possible value. So then that would be the order. Now because it is in points, it is very difficult at first glance to find out what is the value, but we can obtain it with sufficient calculations. So I hope you understood this question well. That is it for this video. Thank you for watching.